Welcome to Shanti-Peace for Mathematics. In my previous video, you probably have learned about the exponential form of a complex number. So that means any complex number z represent as r into e raised to I theta, where e raised to I theta is equal to cos theta plus I sin theta is known as Euler's formula, and that Euler's formula proof also I have discussed in my previous video. Today we will discuss about the De Moivre's formula. The formula is actually a generalization of e raised to I theta raised to n equal to e raised to I. Equality is true for every n belongs to n, that we have already discussed in the previous lecture. So here actually the statement is like this: for any n belongs to n and theta belongs to r, prove that cos theta plus I sin n theta power n equal to cosine theta plus I sin n theta. So this is the statement of De Moivre's formula. So we are trying to prove this formula using principle of mathematical induction. So PMI is the tool to prove this one. Obviously the result is true for n equal to 1. So clearly result is true for n equal to 1. That you can see by if we put n equal to 1 here, this is cos theta plus I sin theta is equal to cos, here n is 1, here is also n is 1. So it is the same identity for both sides. Now let us try to prove the result is true for n equal to 2. We'll start with the cos theta plus I sin theta square. So that I can write as cos theta plus I sin theta into cos theta plus I sin theta. Now if you multiply these two brackets, you will multiply this cos theta with cos theta, that is cos square theta, and if you multiply I sin theta with this I sin theta, that is I square sin square theta. So I square will become minus 1, so that's why it is minus sin square theta, plus there are terms of with I. So this I sin theta will multiply to cos theta, so it is sin theta into cos theta, and also this cos theta will multiply to this sin theta, so that's why it is I sin theta into cos theta. So it is 2 times I sin theta into cos theta you will have. So this will be gives you cos 2 theta, plus this is 2 sin theta into cos theta will gives you sin 2 theta. So that means we can say that the result is true for n equal to 2. As you know the principle of mathematical induction, we have to assume that the result is true for n equal to k. That means cos theta plus I sin theta power k is equal to cos k theta plus I sin k theta. K is belongs to n, which is less than. Now we'll start with the cos theta plus I sin theta power k plus 1. That means we need to prove now the result is true for k plus 1. So this we can write as cos theta plus I sin theta power k into cos theta plus I sin theta will have. Use this result, that cos theta plus I sin theta power k is cos k theta plus I sin k theta. So the for k this result is true, so that's why we can write as this is cos k theta plus I sin k theta into cos theta plus I sin theta. Now again you multiply these two brackets is the same manner as we have did above. So that is cos k theta into cos theta, because this cos k theta will multiply to cos theta, and I sin k theta will multiply I sin theta. So that is I square will become minus 1. So sin k theta into sin theta, plus there are terms with I, so that this I sin k theta will multiply cos k theta, sorry cos theta. So sin k theta cos theta, plus this cos k theta will multiply with sin k theta, so that is cos k theta into sin theta, Now what is this? It is the using the formula cos alpha plus beta, we can write as this is cos k plus 1 theta, because this is k plus theta, theta if we common out we'll have this, plus I. This is also formula of sin alpha plus beta, so that is sin k plus 1 theta. So due to that, what we can say is result is true for n equal to k plus 1. So hence by PMI we can say that the result is true for any n belongs to, and that completes the proof of the De Moivre's theorem. So it is a corollary of this result, we can say that it is also true for integer. That means for any n belongs to z and theta belongs to r, prove that cos theta plus I sin theta power n is equal to cosine theta plus I sin n theta. So for integer also this result is true, that we are trying to prove. So for that I am starting with cos theta plus I sin theta power minus 1. So that we know it is, we can write as cos theta plus I sin theta 1 upon this we can write. I am multiplying and divide by cos theta minus I sin theta. So now what is the numerator we'll have is cos theta minus I sin theta we have here, and in the denominator this cos theta, so it is of the form a minus b and a plus b. So it is a plus b, a minus b, so it is a square minus b square, and so it is cos square minus I square sin square. I square will become minus 1, so it is cos square plus sin square, which is 1. So we'll have the cos theta minus I sin theta. That means cos theta plus I sin theta raised to minus 1 we can write as this, and this quantity I can write as cos of minus theta plus I sin of minus theta. Why? Because cos is an even function. So cos of minus theta will be cos theta, and sin is an odd function, so sin of minus theta will be a minus sin theta. So we can write, so this result is true for minus 1, so that if you replace n by minus 1 the result is true. Now I am taking as for, let us consider n equal to minus m, where m is belongs to n, so that means I am taking a negative integer. We'll start with that cos theta plus I sin theta power n if I have, then we can write as cos theta plus I sin theta power minus m. This we can write as cos theta plus I sin theta power minus 1 whole power m. So this will gives you cos of minus theta due to this result plus I sin minus theta. So that's we have proved whole power m. And for De Moivre's theorem or De Moivre's formula gives you this is cos of minus m theta plus I sin minus m theta, because m is a natural number, so that's why we can write that is at in this form. So and that minus m is nothing but the m, so that is cos n theta plus I sin n theta. So if you have the negative integer, then this result is true. For positive integer it is also true, and if n is 0, if n equal to 0, then also the result is true, because this is the cos theta plus I sin theta power 0, that will be 1 on this side, and cos 0 will be 1, sin 0 is 0. That means the result is true for any n which is an integer. Now the question arises whether the result is true for any rational numbers. That means cos theta plus I sin theta power n equal to cos n theta plus I sin n theta, whether the result is true for n belongs to q. So for that I am taking an example. For example, I will take theta as minus pi and n equal to 1 by 2. Then what will be this side? Let us calculate. Cos of minus pi plus I sin minus pi whole power 1 by 2 will gives you cos of minus pi is nothing but the minus 1 and sin pi is 0, so it is minus 1 raised to 1 by 2 on this side, and the other side what is you have here, it is cos of 1 by 2 minus pi plus I sin 1 by 2 minus pi, and you know that cos pi by minus pi by 2 is 0 plus I sin minus pi by 2 will be minus 1, so it is minus I, and you can say that it is a square root of minus 1, so it is I. Okay, and so these two results are not true for if you consider your rational n as a rational number, but we can state this result in this manner. If theta is a real number and n is rational and your theta is between this interval, that means it is a principal argument. If it is a principal argument, then you can write as cos theta plus I sin theta power n is equal to cos n theta plus I sin n theta. So that is the next corollary we can have, and this condition is necessary due to this example that we have discussed here. So to prove that, what I will start with cos theta plus I sin theta, that I can write as cos q by q theta plus I sin q by q theta. For any q belongs to n, this is true. Now as q is a natural number, so this q I can take outside. That means by using the de Moivre's theorem, we can write as this is cos theta by q plus I sin theta by q whole power q. Now taking qth root both sides, we get cos theta plus I sin theta power 1 by q equal to cos theta by q plus I sin theta by q, and n, which is a rational number which is of the form p by q, where p belongs to z and q belongs to n, if I have, then if I start with the cos theta plus I sin theta power n, that is cos theta plus I sin theta power p by q. So this we can write as cos p theta plus I sin p theta, due to the result is true for integer. Due to this result, we can write this as cos p by q theta plus I sin p by q theta, and p by q we denoted as n, so this is cos n theta plus I sin n theta. So that means this result is also true for if n is a rational number. But yeah, there is a restriction on the theta that you have, which is theta has to be a principal argument, or theta is between open interval minus pi to close interval pi. Obviously the next question you should ask is what should be the result if cos n theta plus I sin n theta is equal to cos n theta plus I sin n theta if n is belongs to R. This is I am giving you as an homework, you can try for this. Yeah, obviously the theta here is the between minus pi to close interval pi. This theta, this restriction is necessary in this, so that I am giving you as an homework. So those students who are interested to do this, they can try for. Now we'll have some application of de Moivre's theorem. In that we solve some examples related to that. Let us consider this example. Simplify cos 2 theta plus I sin 2 theta power 1 by 3 into cos 3 theta minus I sin 3 theta power 2 by 3 upon cos 3 theta plus I sin 3 theta power 2 into cos 5 theta minus I sin 5 theta power 1 by 4. So to simplify this, let us have this expression. We know that this result, that is de Moivre's formula, is true for an integer. So that theta cos 2 theta plus I sin theta we can take out. So that is cos theta plus I sin theta power 2 by 3. Here the result is also true for minus 3, because this expression I can write as cos of minus 3 theta plus I sin minus 3 theta. So the result is true for an integer also, so that's why we can write as this is cos of theta plus I sin theta raised to minus 3 into 2 by 3 upon, here you will have cos theta plus I sin theta raised to 6, because this 3 goes here, and this will be cos theta plus I sin theta whole raised to 5 by 4, because minus 5 by 4, because this will we can write in the same manner cos of minus 5 theta plus I sin minus 5 theta. So that will gives you minus 5 goes up, so that is minus 5 by 4, and so this expression I can write as cos theta plus I sin theta is 2 by 3 minus 2, because the power will add here, 3 will cancel out, so it is 2 by 3 minus 3, and this 6 will goes up, so it is minus 6, and this is plus 5 by 4. So if you simplify this, you will get cos theta plus I sin theta power minus 31 by 12, and so that's we can write as cos of 31 by 12 theta minus I sin 31 by 12 theta, because of cos of minus 31 by 12 will be cos of 31 by 12, and sine of minus 31 by 12 will be minus of that, so that's I'm taking out from that. So that's a simplification of the above expression. The next example I'm taking as evaluate 1 plus I root 3 raised to 90 plus 1 minus I root 3 raised to 90. This is the power of some quantities. Whenever such kind of examples, when you have to calculate the power of some complex number, the easiest way to simplify your rectangular system or this Cartesian coordinates into the polar form. So that is the better way to represent the number into the polar form, and then use the de Moivre's theorem to solve them. You will have the easy way to compute this. So for that I am taking as x is equal to 1 and y equal to root 3. So if x is 1, y is root 3, r will be x root of x square plus y square, that will be gives you 1 plus 3, and that is 2, because root of 4 will be 3. And theta, you will have, see here the x is positive, y is also positive, that means your point is lies in the first quadrant, so that's why this will be a tan inverse of y by x, and tan inverse of y by x is tan inverse of root 3, and tan inverse of root 3 will gives you pi by 3. So 1 plus I root 3 I can write down as 2, that is r, into cos pi by 3 plus I sin pi by 3. And 1 minus I root 3 I can write down as 2 into cos pi by 3 minus I sin pi by 3. That I can get by taking conjugate here. So if you can take conjugate here, so conjugate both sides will gives you this. Now we need to express, or we need to simplify what will be the 1 plus I root 3 raised to 90, 1 minus I root 3 raised to 90. So if I use this expression, this is 2 raised to 90 here, and so 2 raised to 90 will come here, and cos pi by 3 plus I sin pi by 3 raised to 90 plus 2 raised to 90 is there, and cos of pi by 3 minus I sin pi by 3 raised to 90. So this I can write down as 2 raised to 90. I can take common from this expression, and using the De Moivre's theorem or De Moivre's formula, I can write down this is as cos 90 pi by 3 plus I sin 90 pi by 3, plus this is also true, so there is cos 90 pi by 3 minus I sin 90 pi by 3. So you can observe that this is plus and this will be minus, that is cancel out. So that is cos 90 pi by 3, cos 90 pi by 3, that is 2 times. So it is 2 raised to 91 cos, and 2 raised to 91, and this 90 upon 3 will gives you 30 pi. And what is the 30 pi? 30 pi is 1, so that is it is 2 raised to 91. So that is the answer for your question. So by taking these two examples, we are having, or from this above example we can have one observation. So we'll have one remark here. So first, if I take z is equal to e raised to I theta, then z power n I can write e raised to I n theta, so that is cos n theta plus I sin n theta, and z raised to minus n will gives you cos n theta minus I sin n theta, because this power minus 1 will gives you minus 1 inside, and cos of minus n theta will be cos n theta, and sin of minus n theta is minus sin n theta. And now I am adding this to z raised to n plus z raised to minus n will gives you, if I add this to, so you can say that this minus I sin n theta will cancel with plus I sin n theta, and this will become 2 times, so cos 2 n theta. And if you can subtract this 2, then you will have 2I sin n theta. If I take this expression, that is z plus z raised to minus 1 power 5. So if I use the binomial expansion for this, this will be z raised to 5 plus 5c1, z raised to 4 into z raised to minus 1 5c2, z cube into z raised to minus 2 5c3, z raised square into z raised to minus 3 5c4, z into z raised to minus 4, and 5c5 z raised to minus 5. So if you simplify this, see what are the terms of z raised to 5 and z raised to minus 5. If I take write down combinedly, z raised to 5 plus z raised to minus 5, because 5c5 is 1, so z raised to 5 plus z raised to minus 5 you will have, and this will gives you z cube, this will gives you z minus cube. So if I write down these two terms combinedly, and 5c1 is 5 and 5c4 is also 5, so that's why we can write as 5 into z cube plus z raised to minus 3 plus, if you can write down 5c2 jointly with 5c3, or this will gives you z and this will gives you z raised to minus 1. So it is 5c2 will gives you 10 and 5c3 also gives you 10. So it is 10 into z plus z raised to minus 1, and due to this we can write here, this is z raised to 5 plus z raised to minus 5, so n equal to 5 in this we have. So we can have here, it is 2 cos 5 theta plus 5 into 2 cos 3 theta plus 10 into 2 cos theta. And so you can express this or simplify this. We can have 2 cos 5 theta plus 10 into cos 3 theta plus 20 into cos theta. And on this side, what is z plus z bar? If z is e raised to I theta and z inverse is e raised to minus I theta, so here is n is 1 actually. So if n is 1, this will gives you 2 into cos theta raised to 5. So that is actually a formula for cos raised to 5 theta equal to 2 raised to minus 4 cos 5 theta plus 5 cos 3 theta plus 10 cos theta. And similarly we can obtain sin raised to 5 theta in terms of sin theta. So this actually calculation will helps you to, in general, cos raised to n theta in powers of cos theta and sin raised to n theta in powers of sin theta. So this observation that you can use to simplify the formulas of cos raised to n and sin raised to n. After doing this, I am giving you 2 exercise and then I will close video. The first exercise I am giving you as an homework, that simplify 1 minus I root 3 raised to 29. Simplify this and find cos raised to 7 theta and sin raised to 7 theta in terms of cos theta and sin theta respectively. So that's it for today's lecture. Thank you for listening me. If you have liked this video, please do like and comment. If you have any questions, you have any suggestion to give a talk on. So thank you very much. Bye bye.